Okay, so normally I do the classwork problems for you, but in this case, I'm going to do the homework one here. I'm going to skip 24, so you can do 24 and 25 for homework. I'm going to do 26. I just think 26 is maybe a tiny bit harder than 24, which is why I'm going to actually do that one for you. And I'll talk about the difference between the two as we go along. Okay, so 26 says the electron in a helium atom has an energy of negative 5.4 electron volts on the ground level. Okay, so what that means is for helium, right, the energy levels are negative 5 point, excuse me, I said 5.4, I meant 54.4, negative 54.4 electron volts over n squared. And so that's the number that we're going to use for helium. Normally in problems, right, we've been working a lot with hydrogen. So for hydrogen, right, the energy levels are negative 13.6 electron volts over n squared, right? So that's for hydrogen only, right? And they tell you that right here in the problem. So that should be pretty straightforward. So here, just to give you a different problem with different numbers so that you're not just doing the exact same problem over and over again, right? They gave you helium for this problem. And they told us that the energy was 54.4, which is fine. So the one that you'll do is for hydrogen. And again, it'll be the same, only instead of 54.4, right, you'll use 13.6 like normal. So the question says here, calculate the first 5 energy levels from n equals 1 to n equals 5. And then part B says, draw the energy diagram, including ground level. And then part C says the electron is on n equals 3, draw all possible transitions. Well, I'm going to start with part B here because it says draw the energy level diagram. Okay, the energy level diagram basically are these lines right here. Okay, so it shows energy level 1, right? So n equals 1 all the way up to energy level 5. So n equals 1, 2, 3, 4, 5. Okay, we draw 1 on the bottom because that's the lowest. Okay, we draw 5 on the top, that's the highest. And now the other thing that you'll notice about my diagram is that the spacings are not equal. Okay, and what we're going to see is that the difference between 1 and 2 is actually bigger than the distance between 2 and 3, right, is bigger than 3 and 4. So as you go up higher and higher, these lines get closer and closer together. Okay, so when it says draw the energy level diagram, really that's all you're drawing is these 5 lines, labeling them. If you label them E1, right, E2, E3, E4, and E5, that'd be fine too. So as long as you're labeling them E1, 2, 3, 4, 5 or n equals 1, 2, 3, 4, 5, that's fine. Okay, so that's B. Part A says calculate the first 5 energy levels, right? So you're just going to use this equation to calculate E1, 2, 3, 4, 5, right? So E1, negative 54.4 over 1 squared, right, because n equals 1, gives us negative 54.4 electron volts. Right, E2 is negative 54.4 over 2 squared. 2 squared is 4. 54.4 divided by 4 gives us 13.6. Okay, E3, negative 54.4 over 3 squared. 3 squared is 9. 54.4 over 9 gives us negative 6.4. All right, E4, negative 54.4 electron volts over 4 squared. That's negative 54.4 over 16. Gives us 3.4 electron volts. And then E5, negative 54.4 over 5 squared is 25, right? Divided, we get negative 2.2 electron volts. All right, so these are the energies for levels 1, 2, 3, 4, and 5. All right, you can keep going, figure out 6, 7, 8, 9, 10 if you wanted to. You don't have to. Probably not too exciting to sit and keep figuring those all out. So that's part A. Here's the energy. Here's the diagram. Okay, and then part C, it says the electron is on the n equals 3 level. Draw all possible transitions. Okay, so remember what I said in the previous problem, that the electron will only ever fall down on its own. So if it starts here, that's why I drew a little splotty thing. All right, the electron starts here on level 3. Okay, what could it do? Well, it could fall down to 2, right? And then it could fall down to 1. All right? So it could go boom, boom, and fall down. Okay? Or it could start on level 3, and it could fall straight down to 1. So kind of remember that analogy that I made before. Remember I said it's like falling down the stairs? All right? Hopefully you don't fall down the stairs. But if you were to fall downstairs, maybe if it was like a big fall, you'd start on the top and you just like almost jump and you'd land on the bottom, right? Or maybe if it was like a horrible fall, right, you'd go bump, 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 and you'd hit every step on the way down, right? So that's what the electron is like. So sometimes it'll fall and it'll start, right, and it'll fall all the way right straight to the bottom. Sometimes it can fall step by step by step down. I mean, it could skip a level. Like if they told you it started on level 4, it could go from 4 to 2 down to 1. It could go from 4 to 3 to 2 to 1. It could go from 4 to 2. It could skip 3 to 1, right? So any possible combination, all right? So you just have to read the problem and see what it says. And usually they give you a low energy level, and then they just ask you to give the different combinations, okay? So that's our answer here for part C. And you could write this out if you wanted to. You could just go E3, right, to E2 to E1, or it could go from E3 directly to E1. So those are the two choices. All right, and that's all we have for number 26. So again, you can do 24 and 25 for homework.